We're almost halfway through. It's 11.4, solving equations involving logarithms. So our objective is that students will be able to solve equations involving logs. So equation involving logs arise in variety of contexts. Most of the time these equations are solved isolating the log and then write an equivalent exponential function. So remember, my little trick that I always remember is the log of 100 is equal to 2. Remember, if no base is written, it's 10. And how do I transfer this into an exponential? This is the same thing as me saying 10 square is 100. So this is like my little cheat to remember what goes where. So in part exercise 1a, it says the log of base 6 of something x is equal to 2. If I go back up here, I see it's always going to be the base. So here I went from 10, my answer, and it's equal to that. So this will be 6 squared is equal to x, and I know 36 is equal to x. That's it. Now what happens here? Same exact thing. It goes 2 to the third is equal to what is in parentheses. 2 to the third is actually 8 plus 5. Go ahead and solve. You have 3 is equal to x. Okay, it's just solving. Now what happens when there is a number in front of the log? Remember, this is multiplication. And then what do? We do the opposite. So just like we would in anything else, let's first get rid of this plus 2. So here I would have 3 log of 5, 4x plus 1. So I need to get rid of this minus 2, sorry, so I'll do the inverse, which is adding 2 on both sides. That becomes 6. Now I need to get rid of the 3, which is dividing both sides by 3. I get the log of 4x plus 1 is equal to 2. Remember, the first thing it says is isolate the log, then set up an equivalent. So now I can go ahead and set up. I know it will be 5 squared is equal to 4x plus 1. You're going to go ahead and solve this. You should get x is equal to 6. If not, we have some big problems because this is only a simple one step, two step. 5 squared is 25. 25 is equal to 4x plus 1. Now let's keep it going. Since each of the above exponential had only one log, it's relatively easy. So notice up here they're only basically one thing versus what we're going to see in exercise 2. It was very easy to isolate the log and then write the equivalent exponential equation. Now when there are 2 or more log, we have to remember the laws. Remember the logarithm laws, which we talked about, the multiplication, division, and the product. So in this case, we would have to set this up. How do we do? What is when I see a subtraction? So remember, multiplication means I'm doing some kind of addition. Whenever there's division, it means I'm doing subtraction, and then the other rule that we just talked about. Now this is a subtraction. They have the same base. So then I'm going to go ahead. Subtraction again is always division. Oops, this is a 1, not an 11, and this is raised to the 3rd power. Now how do we go ahead and solve this? So I want to go ahead and solve this. Now we do the same thing. Set up an equivalent exponential, and then we can go and solve this. So this becomes 2 to the 3rd is equal to 3x plus 23 over x plus 1. We know 2 to the 3rd is actually 8, so we can write that out. Let's just get some space here. Extend this out. So now that we have this is the same thing as writing cross multiplying, because this is 8 over 1. I want to cross multiply. I have 8x plus 1 and then 1 and 3x plus 23. So I'm not going to cross this line here. Now if I go ahead and distribute, I'm going to end up getting 8x plus 8 is equal to 3x plus 23. Now how do I go ahead and solve this? Minus 3x on both sides, it's 5x plus 8 is equal to 23. I'm sorry, yes, minus 3x on both sides, minus 8 on both sides. What do you get? So now I have 5x minus 8 on both sides. Sorry, I get 15, and x would be 3. Okay, and the only reason why I was able to do this is because this is actually the division law. With addition now, which law are we going to use? Perfect. We are going to use the product law. So this is actually the same thing as me writing the log of x parentheses x minus 3. Remember, that's the product law when I multiply these two. Now going ahead, remember no base is written, so that means it's actually a base 10. Good. So this will be x parentheses x minus 3 is equal 10 to the first power. If we go ahead and we distribute this, this becomes x squared minus 3x is equal to 10. Notice x squared tells me that this is actually a quadratic function, meaning I'm going to get two answers and one of them will be rejected. So make this into a quadratic. We have x squared minus 3x minus 10. Solve it really quick. A is 1, B is negative 3, and C is negative 10. So if I go ahead and solve this, it becomes negative 10, negative 3. Two numbers will be negative 5 and a positive 2. So when I factor this, it becomes x minus 5 and x plus 2 equals to 0. Now what two answers do I get? The two answer choice is either x will be a positive 5 or x will be a negative 2. Now which one do I reject? I reject negative 2 because that's not in the domain. Remember, your log function is never negative. X is always greater than 0. So my only answer that's left is x is equal to 5, and that's it. Okay, that was a little longer. Now, what do you think about exercise 3? It says determine the intersection of these 2 points. This is more of an application kind of short response question. What am I doing? The intersection of these points. When I'm being asked for intersection, it means that somewhere along these lines, these two things are going to be equal. So the first thing I want to do is set these equal to each other. Has to be equal to the log of 3x plus 1 plus 5. Now, what do I do? How do I set these up? What happens with these here? Now what I can do is I can manipulate this so that I get all the logs on one side and then my numbers on the other side. So I will keep my log of 3 x plus, I want to bring this over, it's subtraction to the log of 3 because I want to get those over to use a product. This was a plus 3, so I'm going to take that over and this becomes a 2. If I minus here, and I'll just do it in a different color, minus 3 on both sides, and then bam, that's what's left. Now that I have this, if you look at this, this is actually a simple log. It's a subtraction, so I know it's going to be log of 3 using the division rule. This is an x, would have to be equal to 2. And from this, I can go ahead and set up my exponential. With my exponential, I'm going to get 3 squared is equal to x plus 25 over x plus 1. 3 squared is 9, x plus 25 over x plus 1. Remember, this is the same as 9 over 1. Cross multiply, and we are left with 9x plus 9 which is equal to x plus 25. Now, go ahead, minus x on both sides. I am going to be left with 8x is equal to 16. Perfect. X is equal to 2. Now, am I finished? I found my value of my x. The question says, what is the intersection point? So I know that x is equal to 2. How can I substitute that in? So, pick an equation. It doesn't matter which one you pick. And then we're going to go ahead and substitute. So I'm going to substitute, because it asks for intersection, x equals to 2. It doesn't matter which one you pick. So the log of 3, and instead of x, I'm going to put 2 plus 25. This should actually give you 6. So the point of intersection is actually 2 comma 6, and that's my answer. And this is, again, is more of a short response kind of question. Let's see. Here we have the inverses. So we actually have a little long lesson today. So we're going to talk about the inverses, which we all know what inverses are. It's switching my x and y. We have been seeing this from Unit 1. So the first step, as always, switch my x and y. And then what do? Solve for y. So let's first get rid of the 2, the log of 5y plus 5. And then how do we make this? Remember, same exact thing. 5 to the base x plus 2 is equal to y plus 6. And then how do I make this into my final answer? Minus 6 on both sides, so 5 to the x plus 2 minus 6 is equal to y, and that's my final answer. Remember, from this step to this step, use your cheat, our little cheat. The log of 100 is equal to 2. Remember, no base is given, that's a 10, which is the same thing as 10 squared is equal to 100. That's how I like to remember it. Alright, how about you pause the video and try B on your own. First, switch your x and y, and then solve for y. Go ahead. Alright, so now that you had a chance to try this on your own, you should have gotten 10 to the x minus 5 in the exponents plus 1 over 2. If you're not sure about something, please come and see me. Now it says, actually our second to last question, it says determine algebraically what is the x-intercept of this function. X-intercept is when we know that y is equal to 0. So let's substitute that. It becomes 0 is equal to the log of 2 x minus 7 minus 4. Then I'm going to solve for log of base 2 x minus 7, and then use my little cheat. 2 to the 4th power is equal to x minus 7. Now what do I get? I'm just going to come up here. 2 to the 4th we know is 16 is equal to x minus 7. Add 7 on both sides. We have 23 is equal to x. So my x-intercept is actually 23 comma 0. There you go. Just remember this little cheat sheet. The base raised to what the answer is equal to what is in parentheses. Now 6 and 7, it says solve for x. What you have to think about here is which product am I, oops, I gave you the answer. Which law am I using? So the first one is the product law because it's addition. And then the second one is the division law. So this is the same thing as saying the log of base 2 9 times x is equal to the log of 2 to the 45. Now if I go ahead and solve these, they're the same base. So all I have is When is 9x equals to 45? And that's definitely when x is 5. And there you go. They're equal to each other. No big deal. This is division, so I want to set this up. The log of 2x plus 1 over 3 has to equal to the log of 5. And then what do I want to do? When is 2x plus 1 over 3 equals to 5? This is 2x plus 1 is equal to 15. 2x is equal to 14. That means x is 7. And you can write all the steps out if you want. That's perfectly fine. The last question. Long lesson. Alright, we're almost there. Solve the following. Be sure to check your answer. So now there's a few things going on here. How do I change this? Remember, we don't ever, how did this 2 come about? So this is the same thing as the log of 4 x to the second power minus the log of 4, 2 is equal to the log of base 4 to the 18th. Now, what do we know? We know that the first part of it here is a division. So let's set that up. The log of base 4, and it's x squared over 2, has to equal to the log of base 4 to the 18th. What do we have? We have x squared over 2 has to equal to 18. That means x squared has to be 36. Take the square root of both sides. X is equal to plus or minus 6. But remember, both of these answers can't work because there's no way x can be negative. So from this, x is positive 6 or x is negative 6. We need to reject that one. Remember, the domain for a log function is everything has to be positive. It's greater than 0. So this is my only answer choice. So you see how these rules, the product rule, the division rule, and the power rule are super important. Here it was the power plus the division. Okay? So you have to make sure you take a look back at that lesson. Alright, I know you've been focusing for a really long time. Now let's go ahead and take a break and do those practice problems. Good luck.